In this video, I will discuss the JEE Advanced PYQ from the topic Electrostatics. This question is based on electric potential due to charge and also equipotential surface. For example, let me take a point charge. See a value Q. Equipotential surface is a surface on which potential at all the points on the surface is same. For this point charge, a spherical shell whose center coincides with the location of the point charge, this is the equipotential surface. Any point on this surface will be at the same distance r. So the potential of this surface V equal to K, which is 1 by 4 pi epsilon naught into Q by this radius r. Let me call it R1. Similarly, if we take another spherical shell of bigger radius, say radius R2, the potential of this, all the points on this surface will be same and will be V2, which is K, which is 1 by 4 pi epsilon naught into the charge, source charge by the distance R2. So equipotential surface is the surface in which all the points on the surface have the same potential. It's obvious from the phrase equal potential surface. So all the points which have the equipotential, which form a surface, is the equipotential surface. Similarly, if you have 2 points, point charges, there will be an equipotential surface, but it will be distorted spherical shell. You have 2 point charges of value Q1 and Q2. Equipotential surface in some form. But suppose you take a simple case where the 2 charges are plus Q and minus Q, like a dipole. For this particular case, if I take a line, this is perpendicular bisector of this dipole axis, and the middle draw a perpendicular line. So all the points on this line is at the same distance from the positive charge and negative charge. So the total potential at this point is K into Q by R, let me call it R1. By symmetry, this also is R1 because it's the middle of this dipole and perpendicular to the axis of the dipole. So R1 due to the positive charge, due to the negative charge will be minus KQ by same R1. So it will be potential will be 0. If you take another point here, the potential at this point, let this distance be R2, and the distance of this point from the negative charge, it is same by symmetry. So this also is 0. So all the points on this line, on this side also, will have the same potential, and the potential is 0. Similarly, if we take a surface which is perpendicular to this plane of this board, the dipole is in this board. So all the points on this surface will be at the same distance from plus charge and minus charge. So the potential of this, all the points on the surface is 0. So this plane surface, it can be infinitely extended. It's an equipotential surface. So this equipotential surface have potential 0. The next equipotential surface will be something like this. Plus some other potential. It will be like a distorted sphere, but this is a plane sheet. So there will be another equipotential surface like this. And this line is called equipotential curve. Like equipotential surface, all the points on the surface have the same potential. Similarly, equipotential curve, all the points on that curve will be at the same potential. Another basic thing which is used to solve this question is equation of a circle. In this xy plane, let the circle be here. What is the equation of the circle? The center of the circle will have some coordinates, it will be a comma b, and let the circle has some radius r, that is this distance. To get the equation of the circle, this is a standard way of doing it. So from this point, with the coordinate of this point b, x comma y, it's an arbitrary point on this circle. Drop a perpendicular from here and a horizontal line. So this will be 90 degrees parallel to x-axis and y-axis. So this distance from here to here, it's x minus e. Because from here to here, which is the coordinate of this point, is x, and from here to here it's e. So this one is x minus e. Similarly, the distance, this one, from here to here, is y minus b. From here to here it's y, and from here to here it's b. So this one is y minus b. So in this right angle triangle, one side is x minus a, this one is y minus b, and this hypotenuse is r. So r square, or by Pythagoras theorem, so this equation of the circle, any point in the circle will satisfy this equation. So the equation of the circle will have x square term, x term and constant, and then y square term, y term and constant, and r square. So another way of writing the equation of the circle is we'll have x square term, and then y square term, and then x term, the coefficient is substituted as 2gx, and then y term, the coefficient is 2f, and some constant c. This is equal to 0. So the equation of this form or of this form represent a circle. Now can we relate G, F and C to A, B and the radius R? So from this the x term is minus 2A x. So that should match with 2G. Y term is minus 2BY, and here the Y term is 2F. And the constant terms here are a square, b square, minus r square if you bring it here. So a square plus b square minus r square. So that should match with c. For these two to represent the same circle. So from the second g equal to, or a equal to minus c, b equal to minus f. Here the center of the circle is a comma b. So from this I'll get the center of the circle as minus g comma minus f. So the equation of the circle in this form, I can find g, and if you put the minus sign, I'll get the x coordinate of the center of the circle. Similarly from f, I can get minus f. So the coordinate of the circle is, of the center of the circle is minus g comma minus f. And the radius of the circle, a square is same as g square, b square is same as f square, minus c, square root of that will give me radius. So from this equation, if I do g square plus f square minus c and take the square root, I'll get the radius of the circle. So with this basic ideas, we can solve this JEE Advanced question. 2 point charges minus q and plus q by root 3 are placed in the xy plane at the origin 0, 0 and a point 2, 0 respectively, as shown in the figure. This results in a equipotential circle of radius r and potential v equal to 0 in the xy plane with its center at B, 0. All the lengths are measured in meters. The value of B is dash meter and R is dash meter. Center of the circle, somewhere here, it's B, 0, and radius of the circle is R from any point to the circle. So here, the potential at all the points on this circle is 0. So if we take a point here, let it have a coordinate x, y. So the distance of this point from this charge minus q, that will be r1, and from this charge be r2. So the potential at this point x, y will be to the two charges at a distance r1 and r2. So the total potential at x, y is to the positive minus charge k, which is 1 by 4 pi epsilon naught minus q by r1 plus k into q by root 3 into 1 by r2. From coordinate geometry, the distance between 2 points r1 I can get it right as x square plus y square, and between these 2 points, so this is at a point 2, 0. Coordinate of this point is given. So this is potential is 0. That means q by r1, q also potential is 0. So this means 1 by r1 equal to 1 by root 3 into 1 by r. This is 0. K will we can remove, q we can remove. So 1 by r1 should be equal to. So this means I can square on both the sides. 1 by r1 square equal to 1 by 3 into 1 by r2. R2 square. You can also take the reciprocal. So r1 square equal to 3 times r2 square. R2 is less. So thrice of root 3 times r2 is r1. Okay, r1 I can use coordinate geometry to get this distance as x square plus y square. That's equal to 3 times. Distance between 2 points is x minus 2 the whole square plus y minus 0 the whole square. X minus 2 the whole square plus y minus 0 the whole square. That is r2 square. So 3 So 3x square, 1x will cancel here, so it will become 2x square, and then 3y square, 1y square is here, so 2y square becomes 0 here, and then x term is minus 4, and then 3, so minus 12x, there is no y term, and the constant term is 4 plus 12. X square term, 3x square, 1x square will go, 2x square, and then y square, 3y square, 1y square is here, 2y square, and then x term is minus 4 times this one, and then 3 minus 12. There is no y term, and then constant term is from here 4, 12. So this I can rewrite as 0 equal to x square plus y square minus 6x plus 6. So this is 2gx. F is 0 and this is C. So the center of the circle is minus G. So G is 3, minus 3. So minus G is plus 3. And then F is 0. So B is 3. And then radius is square root of G square. G is 3, 3 square 9, plus F square is 0, minus C. C is 6. So this root 3 meters. So radius is root 3 is 1.732. Radius is 1.73. Value of P is 3. So this is the correct answer. So this we have to compare with the standard equation x square plus y square minus 2g plus 2gx plus 2fy plus c equal to 0. From this we can find g, f and c. And center of the circle is minus g comma minus f, and radius is square root of g square plus f square minus c.